Hello, welcome back. This is the third video for the rectangles um, notes. So it's 8.2. We're working with rectangles. I didn't complete all the problems for you from the homework. I'm just going, so there's 1 through 4 is on your own. Use the previous videos to answer those. This one is a little more complicated, so I wanted to make sure that I went over this one with you. Now, what we have is we want the measure of the acute angles made by the diagonal in this case. So the diagonal is 8 inches long and the side length is 7 inches long. Basically, what we want to do is find that. We're going to call it theta. We usually call missing angles theta. Back when we talked about trigonometry. So we're going to continue to do that. This is a trig problem. Now, relative to this angle, if you're just looking at this right triangle, okay, just highlight that one. I want you just to focus on this right triangle. So what we're going to be using is right triangle trigonometry. What I do first is I label the sides relative to the acute angle that I'm going to be working with. So first, hypotenuse is across from the right angle. Second, relative to this angle, there's two legs. The one that's not touching that angle is the opposite leg, and the one next to is the adjacent leg. Now, if you remember from our chapter in trigonometry, we have an acronym we use to figure out what is the best trig function to use for this particular problem. You can use any of them, but there's one that is best. Now, in this case, it would be best to use the one that has adjacent and hypotenuse. Okay, that would be cosine. That's what this acronym is looking at. So cosine is the trig function, and it equals the adjacent. It gives us the ratio of the adjacent side to the hypotenuse. So now the mechanics of it, that's something that is different for a lot of teachers. I like the mechanics to look like this. Okay, I pick the trig function, cos, then I put in the angle in parentheses. Now, cosine is the ratio of two sides. It is always going to tell us to go adjacent over hypotenuse. So I try to convert it. That's my first step in my mechanics. Now I still don't know theta, so I'm just going to leave that. I do know the adjacent side is 7 and the hypotenuse is 8. Now, a lot of teachers don't make you convert the decimal, so this is an optional step. Okay, I like students understanding that, this number is going to go into the cosine function, inverse cosine actually, and give us an angle measure. I change it to a decimal. You don't have to. Okay, so a lot of teachers will not show that step. That's an extra step. All right, this is essential for your understanding though. I want to get at theta. I want to get rid of cosine. We can't divide to get rid of a function. We have to do the inverse function. Now the inverse function of cosine is cosine of the negative first, or cosine inverse. Now whatever we do to the left, we should do to the right to keep it balanced. All right, now inverse functions basically knock each other out, and what we're left with is that variable in there. Okay, now we type this in the calculator. This is evaluated by the calculator, and back to that. That angle is 28.955. So I'm going to assume they wanted the nearest degree, and that's theta. All right, now going back up here, okay, so there's a couple of acute angles formed. All right, if this one's 29, then that one is 90 minus 29, which is 61. This one's 61, this one's 29, and that one's 90. Just to be thorough, we're going to fill in all the angles. All right, there it is. Okay. It also wants us to find the perimeter. Okay, I didn't do that part yet. So I did the angles. You can do perimeter on your own. That's going to be Pythagorean theorem. I'll get you started. We'll call that x, right? You'll do 7 squared plus x squared equals 8 squared. So for x, you'll get a decimal. And then what you'll do is you'll add up 2 of the 7s and 2 of the x's. That can be on you. You don't need my help with that one. All right. So what I'm going to do is I'm going to complete this problem, and then there's another one like it on your homework. You can do it the same way. Okay. So prove quadrilateral is a rectangle, and you have to complete this one as well on your own. But I'm going to go through the process with you. So first, we'll go ahead and put on our axis. We'll plot the points. So this is where I have it. Okay. It'd be best to use a straight edge there, but I don't have one. All right, so what I'm going to do instead of using the formulas, I'm going to count it out and show it on the diagram. Now, you're welcome to use the formulas. It's a great idea to learn them. I'll do one with the formula. The rest, I'm just going to use the numbers there. Evidence. Now, in our coordinate geometry or analytic proof, okay, so in our analytic or coordinate geometry proof, we have 3 choices for our evidence. You're either going to calculate slope, length of the sides, or you're going to calculate the midpoint. Now, midpoint's out. You could probably do some length, but we don't need it for a rectangle. So let's go with slope, and the goal is to show that they're all right angles. That is going to be, we're searching for slopes that are negative reciprocals. So what we're going to do is, for our evidence piece, is we're going to calculate. Now, it's always one of these 3, and in this case, slope of each side. It is really good communication to actually let the person grading your paper know what you're actually trying to do. Now, I'll put one of them here with a formula. Okay, so the slope formula, everybody should know lowercase m is what we're going to do for slope. We're going to show for slope. Now, what I'm going to do is take this formula. It's y, you could see it y1 minus y2 or y2 minus y1. Doesn't make any difference, just be consistent. So let's say I'm going to take the slope of AB. I'm going to call that x1 and x2. Now that's going to go on the bottom. This is very easy. Okay, so my bottom, I'm going to make that 1, take away negative 5. Now I'm going to go to the top, that's your y's. This is y1, this is y2. So it's going to be negative 4, take away 0. So it's going to be negative 4 over 6, negative 2/3. Okay, so you could use the formula. I don't. I typically just count, but I show the numbers on the diagram. So for AB, slope, I'm going to rewrite it. Negative 4 over 6 is negative 2/3. All right, now I'm going to go to BC. My slope there, I'm going to use this. It's going up as we move left to right. So it's a positive slope. Rise over run is 6 over 4. That reduces to 3 over 2. CD. Now I know it's the same as this, but just pretend you're actually looking at it as you write it. Okay, so just play the game a little bit and make it look like you actually went up to the diagram and used that. All right, that is what we call our evidence. Okay. Now, with that evidence, we're now going to make statements and justify those statements. Now, these slopes are, you can see, negative reciprocals. Okay, what that's eventually going to get us is right angles. But let's make the first step. What I should say is a statement such as AB is perpendicular to BC. Okay, AC is perpendicular. We can do this all in the same statement. It's going to all be for the same reason. CD is perpendicular to AD, and AD is perpendicular to AB, and then just justify that because their slopes are negative reciprocal. Please don't say because they are negative reciprocals. You have to specifically say their slopes. Now, what are you actually working with, their slope? Okay. Another conclusion before our summary. Another conclusion is now we're going to talk about angle A, angle B, angle C, and angle D are right angles. Why? And that's because perpendicular segments create right angles. All right. Finally, we summarize this. What does it do for us? Okay. ABCD is a rectangle, which is what we want to prove, because it has 4 right angles. There it is.